I've made quite a bit of progress since the ending of part 1, video part 1. And at this point, I've got the old supply pretty much taken apart. This is the old Radio Shack transformer. And here's the case. And I've got a little bit of a challenge here with the capability of fitting all of this in one case. The transformer actually takes up quite a bit of room. I've got the board here with the basically this is the power supply itself. It just needs to be fed by the transformer and wired to the gauges and switch and all the external devices. But I had a tough time trying to get this board in here. You know, it's just not going to fit. And so I thought front to back, which it will fit sideways, but the problem with that was that the front panel here was a little bit of a problem because the gauges are very deep and just really not enough space. Let's get the back here. Not enough space really to arrange it that way. A little bit concerned about the 120 volt feed of this transformer and on the supply side, and then the load side would be close to shorting. So there's just not enough space to really make that work very well. So what I ended up doing was a layout, and I didn't make a scale drawing of this. I kind of wish I would have. Might have averted some of these challenges, but what I ended up doing was deciding to put the board in this track, which I can do like that, and then this transformer will sit right next to it. And there's at least a 1/4 inch between the transformer terminals and any other metal in the case. And front gauge assembly sits like that, so that's at least 1/2 inch, plenty of space. The back panel, I basically put this not centered but set up so that there would be just enough space. So there's plenty of room. There's another 1/2 inch there between the minus terminal and the capacitor case there. So that worked out really well. Transformer is actually going to be back here over those holes, and the reason for doing that is I thought I should leave some space in here in case I ever want to maybe add another fan or whatever. On this power supply board, I did say in the first video I was going to add a fan, and this is it. That is 25 mil, I think, square. Does not move a lot of air, but it doesn't really matter because I don't think this even needs a fan. Oops. Because I've used it before, and this was connected to the outside of the case on the old supply, and the case got warm, but it didn't really get out of control. So I think with this heatsink, I probably don't need a fan, but I'm going to probably hot glue the fan in here if I can get it the right way. I may just hot glue it to the end of the heatsink like that, and that should be just fine. It's almost more just to have some fun doing it than it was really a practical need. And then this enclosure does have mounting feet on it, or mounting feet. It's got feet on it, so it doesn't scratch the table. I did have one issue here. The bench just isn't big enough. One issue here with the front panel. Basically, I started putting the screws in, and then I realized that this hole that's the factory hole, that was actually aligned with my voltage adjustment potentiometer, so it would actually, the screw would actually hit the case of that before it was tight, much before it was tight. So I ended up adding another hole just on the outside for the screw. So that was just a very easy fix, but it was kind of a small crisis when it happened. So I wanted to also add this fuse. This old supply did not have a fuse in it, and I've got this old one from the good old days of Radio Shack when I was riding my 10-speed bike to go get parts. This is good for 10 amps, and it'll be running at 120 volts AC, so it'll probably only see about, I don't know, maybe half an amp, so it's plenty big. I did have some other fuse holders that could mount from the back on the outside and actually, you know, are removable, replaceable from the outside, but since I don't ever expect the fuse to blow, I'll be using this, and it's from the old stash, and anytime I can use up the old stuff, that's always a good thing. In comparison to what I said on the first video, I wanted to cover some things that I changed. I ended up deciding to keep using the LM317K. This is limited to 1.5 amps maximum output. It's self-regulated, so it will not destroy itself if it sees a lower resistance, so that it will try to draw more than that, but it'll just self-limit at 1.5, which is fine. The only thing is, you know, this meter, this ammeter only goes up to 5, so I'm going to be operating it down in this range, which isn't great, but I could not find an ammeter that matched this voltmeter to get a matching pair where I could have 15 volts and 1.5 or 2 amps full scale. So I'm just going to live with this overly large scaled ammeter. I did mount the LED. This is I just decided to use a yellow LED because it was one I had in stock, and it's the only small one I had that fit this bezel. This is a 3mm LED that fit this bezel, and I didn't care if it was yellow or what, but its bezel was a little bit loose in the case, so I added a little silicone around it, and now it's nice and tight, so that's all good. This is the switch from the old supply. This is a new potentiometer, because I didn't mention it in the first video, but one thing I needed to do on the old supply was change that because it had a few bad spots on it. The worst one, I think, is if you turned it almost all the way down, it would go up to full voltage, and I had let the factory smoke out of too many components when that happened, when I adjusted all the way down, so I ended up just replacing that from another one in stock. The resistance was higher on this, so I'll add a compensating network to get the right resistance to a full scale of around 15 volts. Let's see, so what else? The point-to-point wiring of the old supply, you know, where I just have components connected to components, was great in that it was fast and easy, but it was ugly and very amateurish. So one thing I really wanted to do was make some PC boards to hold all the components. So out of the old power supply, I've got this PC board that I made. It's the first time I've ever etched PC boards, and I went through quite a bit of trial and error to kind of optimize the process. So now I can make boards, I believe, correctly every time. So it's a very satisfying process to go through all the steps. And there's artwork involved. I like art. I like drawing things. There's, of course, the circuitry involved. I like that too. So this is all just what I like to do. Got some filtering capacitors. This one wasn't the old supply. These two are added. I've improved the ripple rejection and some other things of this as I went along. Got the dropping resistor for the LED, the yellow LED. These wires will be for the potentiometer to adjust the voltage. And then over here I've got the output to the terminals on the back, and then the wires right next to it to the voltmeter to get voltage indication. And this big aluminum chunk is a free part out of the long gone, happy to see it go, rear projection TV. That was, I think, over 10 years old, and now we've got the LED flat screen. It's much better. So my oldest daughter that is in engineering school now took a screwdriver and took out all the parts of that TV. So I ended up only saving the aluminum heat sinks and a lot of this white wire. I've got tons of this wire from that TV, and I'm using it up, so it's great. You know, it's 300 volt rated. I think it's 26 gauge. So it's only for signals. And I do have some of this heavier 18 or 16 gauge wire out of that TV, I think, also. So that was pretty satisfying to, you know, not let all of it go to the landfill. And so on the circuit board, you know, I've got all the, if I can focus, I've got all the silk screening on here to label all the components so they're inserted properly. And on the back, you can see this is a single-sided copper board, so there's only copper on the reverse, on the back side, or the bottom. And so I haven't cleaned this yet, but I've got some very good traces, very sharp trace lines, and I can etch even down to under 1/100th of an inch reliably, so that's really good. So when I make very compact, high-density boards, that's going to be important, and I'll show you one next. These two resistors are actually to get 460 ohms, and it's to set the calibration of the regulator voltage output, and the recommendation in the datasheet is to mount that directly to the regulator pins. So that's why it is on the bottom. That is not an error. I didn't forget to build that into the PC board. These screws, or actually machine screws or bolts, hold the regulator in place and makes a sandwich with the heatsink. And so that is all at 6 volts, right? This, not 6 volts. This is all at the output voltage, whatever it is set to, 1.5 roughly to 15 volts. And it is isolated now from the case and from ground and from everything else. In the old supply, this output was connected right to the case because the regulator was using the case as a heatsink. So I've solved that problem, and now we have an isolated output power supply. The other thing with that power supply is it will have a 3-wire plug cord set, so I'll bring a ground in and actually ground the case, and the case was ungrounded before with that 2-wire plug, which was fairly dangerous, and I'm glad to see that go. So in the next video, part 3, we'll cover the fan speed controller for this guy, or any DC fan. You can get it out of power supplies or wherever. This is a bigger one out of a server power supply, and these tend to be great at moving air efficiently, but they tend to whine, and I find the whine very irritating. And that's enough motivation to design a speed controller in itself. But I also I just thought it'd be kind of cool to have this fan only run when it gets warm enough, and then to speed up as it gets warmer. So I just thought I'd make a circuit for that, and that was quite an interesting challenge or project. So I'll cover that in part 3, and that's it for part 2.